things, and I'm recording this as well, so I'm going to record the instructions on how to find the recording. It's been taking me painfully long to upload and embed the YouTube videos, but they are all getting uploaded to my YouTube channel. Now, here is how I put the date on my videos. Of course, if you don't forget this and can't find this video to learn how to find videos, you're kind of trapped. But
your clock is off by an hour.
I know. Congratulations. It's been like that since daylight savings times. You're quick.
Same time, but minutes.
So the date I put on all the videos, the first thing I put on every video I upload is the date, and for today's date, it will look something like
2010.
this.
April
2010. Yeah, this way if you sort files, it actually always sorts by date first. Then I will put the class,
Algebra 2.
Algebra 2, and then the topic of the day. So for today, this is going to be more exponential fun.
Creative.
I'm feeling really creative today.
I haven't had any fun yet.
Wait, Mr.
How am I
Belva,
supposed to have
maybe if
more?
you empty all the videos, like the old ones from your...
No, that
It won't work?
No one
Do that?
uses the other ones anyways.
Because we don't use
No
it,
one
like from
uses
last
the
I might try that, but I gotta
Good
sit down and
idea.
clean it. I gotta sit down and fiddle with that. I think Weebly's just getting popular and overloaded. But
It's getting popular?
anyway, let's get on with this here. So it'll be titled something like this. If you put in this date and this topic. Oh, first if you find my channel, which is under my name,
You have a channel that's
you have to have one to upload.
You
Yes.
just search monkey.
It's 99.9% math, and I think the rest is monkeys. So, if you go to my channel first, search for mine, but if you put in my name, the date in this format, and Algebra 2, you should be able to get the lecture on that day. It's usually in 3 or 4 or 5 parts. I may try and put these instructions on my website, or they may magically get faster, and I may actually get the videos embedded. But you can always find it here. If you find my channel, you can go and just hit Algebra 2. You can go searching for everything from the year. Look for the topic you want. Yes?
Why don't you just what are they, like a blog? Why don't you just make a blog?
Blog's fun.
A website. Your own website.
That is what I'm doing, but it's been very slow to upload video lately.
I mean, it's not gonna
Have a
just
math
like
blog.
whatever you want.
Math
Yes,
and monkeys.
but that doesn't mean it goes fast.
You could call your blog Math and Monkeys.
Math and monkeys, I love it. Okay, here we go. Now, to actually get to the homework, Yasmin, you had a question from it.
Number 35.
Number 35. Okay, and this is on page 470. So number 35 is y equals 4 times 5 to the x minus 1. Okay, what is the parent function, the simplest version of this?
Y
Yeah, how
equals
do you
5
do the
to the
extra
x.
Pardon?
How do you do it?
Is it 4 times 5?
Hold that thought. We're going to get to that. Okay, the parent function, the simplest one, this is an offspring of the function y equals 5 to the x. And y equals 5 to the x has 3 points that I'm interested in. The negative 1, which gets me the 1/5. The 1, which gets me the 5.
No,
Nope,
0.
I'm lying to you and I don't mean to. In order, it's the 0, which gets me the 1, and then it's the 1 that gets you the 5. Those are the 3 points I'm interested in. Unfortunately, since kids never do what their parents tell them to, the offspring function doesn't go through these 3 points. Okay? But I want the 3 points that correspond to this.
Find its own points in life.
It will find its own points in life. It will make its own way. So for y equals 4 times 5 to the x minus 1, I want you to use 3 different x values. And the way I told you guys yesterday to find those x values was take this counterintuitive shift that's right here next to the x and apply it to these x values.
So what?
So your next table is going to be, okay,
0, 1, 2.
yep. Laura, remember how every time we add right to the x, it's always counterintuitive?
No.
Like on the graphs, like on vertex form of a parabola, if it was -1, things move to the right.
Oh, yeah.
Okay, that whole rule. So take whatever's being subtracted from the x here and add it to these 3 numbers.
So it's the opposite.
Yeah, so it's the opposite. So like Sarah just said, make this 0, 1, 2. Because of what's been, being done to the x. Then, take this. Deal with your stolen car trade some other time, okay? So now, take these 3 numbers and plug it into this, and you'll get the 3 points that I most want to see. You graph.
So the other table doesn't...
This other table is just for like perspective, to help you see where it comes from. Well, no, in this case there's a ×4, so that's going to be annoying, but...
I thought you didn't have to plug in. I thought you could just do 4 times and then the number on the y-axis on the, for the parent.
That'll work in this case, yes.
Right.
But if you're unsure about, if you don't remember that trick, what'll always work is plugging it in. Also, Brian, if there's like a +3 at the end or something, then that will change that.
So basically the 1 is just there for the table.
Yeah, this is just here, yeah. And now what happens over here with the 0, 1, 2, what you are going to get is 4/5, 4,
Are you plugging it all in?
and 20. Yep.
And then you plot those.
Then you plot those. Now, since there's no h at the end, since there's nothing being added or subtracted to the end, the asymptote is not going to change. That's the other big thing you have to watch out for.
It was the asymptote.
The asymptote is the horizontal line that an exponential function snuggles up to.
Wait, how do we know what?
How do we know which what?
What?
The asymptote is? The asymptote is the x-axis unless you have a +h at the end. Unless you have something being added to the very end.
But that is that in?
Well, now we got to graph it.
No, I mean, if it's the h at the end, is that the asymptote?
Yes, the h at the end will be the asymptote. That's what we said yesterday. Okay, so this one, the x-axis is going to be the asymptote. If you've forgotten, this is x, this is y. 1, 2, let's see. This is going to be a little bit annoying. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, so close. 18, 19, 20. Okay, so 4/5 is almost 1, right? Is that correct?
Yes.
And then at 1, this thing is at 1, 2, 3, 4. And then at 2, it's all the way up at 20. Artur, did you like how I didn't skip anything on my scale this time? Okay, so now what I need you to do is make it look like it's snuggling up to the x-axis and then curving up through these 3 points. It can be a little bit hard to do, but I want to tell you guys something about how functions work. Because this is a function, it has to pass that vertical line test we talk about, which means this can never get vertical. Also, this keeps snuggling up to the x-axis forever, getting closer and closer without touching it, which means you can't draw it curving back up like a parabola.
Wait, is that too snuggled?
No, that's good. I know you didn't mean to have it touch there, but it's like a game. How close can you get to it without touching it?
It's like the snake game, and then you get the...
Oh, no,
I love that game.
Sure, whatever you all are talking about. Okay, so any questions on this one?
Wait, yeah.
Yes.
It also asks us for the domain and range, right?
Okay, domain and range. Hold off on those. We'll go over domain and range, but I'm going to
Let's just skip on.
put it off as long as possible.
Oh, so
We got to talk about it a little bit, but not yet. Yes.
Just to make sure we got it. We'll just plug the x values into that.
Plug these x values into this equation. So this is 4 times 5 to the 0 minus 1, which is 4 times 1/5. This is 4 times 5 to the 1 minus 1, which is 4 times 5 to the 0. And since 5 to the 0 is 1, 4 times 1 is 4. And this is 4 times 5 to the 2 minus 1, which is 4 times 5 to the 1. What's actually happening here, Yasmin, is you're getting... These exponents are the same exponents you would wind up with over here. So it winds up being 4 times 1/5, 4 times 1, and 4 times 5. That will work consistently, but if there's a number at the end, then you've got to add that number in as well. So if you think you're going to get confused,